video we're going to go over trigonomic ratios and how we can use those to calculate lengths on right angle triangles. So first we're going to show you how to label the sides of a right angle triangle. Then we're going to introduce SOHCAHTOA to help you remember which trigonomic ratio you need to use. And then finally we'll go through a few calculations. Now first we need to be able to label our triangle. Now with our right angle triangle, the longest side is always going to be called the hypotenuse. So I've highlighted that side, and that's never going to change for us. So it's always going to be the same. Another quick way you can use to remember it is the hypotenuse is always diagonally across from that little right angle symbol. And that will never change. So that will always be a good place to start when labeling our triangle. The other two sides will be either the opposite or adjacent, but these are named in relation to the angle that we're given. Now I'm going to go through a few examples here, but normally what I like to do is first label the hypotenuse because that never changes, and then go through and use a few little simple tricks to label the opposite first and then the adjacent, and then you're pretty much done with the labeling. So first, if we have an angle down the bottom there that I've highlighted in red, once you've labelled your hypotenuse, drawing an arrow directly across from that angle will always be the opposite. And if that side's the opposite, then the only other side left must be the adjacent. Okay. Now another example, so the angle is on a different side, but again if you draw that arrow across, once that arrow is directly across from that reference angle, that's going to be your opposite. Now that we have the opposite and the hypotenuse, the other side must be the adjacent. Okay. There is ways to get the adjacent, so if you think of the adjacent as just the one closest to that reference angle that isn't the hypotenuse, you can always do that, but I prefer doing the opposite way. Okay. Now moving on to the trig ratios. So we have SOHCAHTOA, and these actually stand for sine of theta, which is that reference angles, equals the ratio between the opposite over the hypotenuse. Okay. Now all of these are to do with the ratios. So then if we have CAH, so C-A-H, that'll be cos theta equals the ratio between the adjacent and the hypotenuse. Okay. So they're always to do with these ratios, and we'll show you in a second how to populate these formulas. And then finally we have TOA, so T-O-A, and this is tan theta, or tan, that angle that you'll be given, equals the ratio between the opposite and the adjacent. So these are very important to remember, and I would write them down if I was you because they're going to come up all the time. Okay, now we're just going to do some examples. Okay, so we have a right angle triangle here with one length 4, one length 3, and an angle of 53 degrees. Now first we're going to label our triangle by drawing that arrow directly across to get our opposite. We already have our hypotenuse, so then the last side must be our adjacent. Now that we have that, we have an adjacent and an opposite, so we can look for which trigonomic ratio to use. So the only one that uses the opposite and the adjacent is tan. So we're just going to populate our formula now. So tan theta, that angle 53, equals the ratio between the opposite over the adjacent. So 4 over 3. Now when you get your calculator, you can put in tan 53 and you will get the answer of 1.327. And if you use your calculator to find the ratio of 4 over 3, you get 1.33. Now the reason they're not perfect is because there's some rounding on that angle. We're just going to do a few examples now. So we have a right angle triangle here where we have a reference angle of 47. Labeling our opposite, we have an opposite of 15, and we're looking for the hypotenuse length. So looking at this, we have an opposite and a hypotenuse, so the only trig ratio that uses both of those is sine. So now we're going to write out our formula of sine theta equals the ratio of the opposite over the hypotenuse. And now we just populate our formula. So sine, our angle is 47, equals the ratio of 15 over our hypotenuse length that we don't know yet. Now we're going to have to rearrange this formula when you have the variable you're looking for on the bottom of that divide or that ratio, you can just simply swap the bottom numbers. So you're going to get h equals 15 over sine 47. Okay, so you can just swap those two numbers. When you put that in your calculator, and you will need to use a calculator for all these, you get h equals 20.51. Okay, and we're calling it units because we haven't put in any things. So we're going to do a few more examples. So here we have another right angle triangle, and first we're going to start by labeling that triangle. So we have an adjacent and we're looking for the hypotenuse, so we're going to have to use cos or co, because that's the only one that uses the adjacent and the hypotenuse. So we write our formula of cos theta equals a over h, then we populate it. So cos 37 equals 41 over h, or x. There's we put. Now again we're on the bottom, so we can just exchange those two bases. So we're going to x equals 41 over cos 37. You'll need to use your calculator again, and you get x equals 51.34 centimeters. Okay, so it's important to remember the units in these. We're going to do two more examples quickly. So here we have our reference angle of 29. We've found our opposite and our adjacent. We don't have a hypotenuse length, and we're looking for that opposite length. So here, the only trig ratio that doesn't use the hypotenuse, is tan, which is tan theta equals the ratio between the opposite and the adjacent. So now we populate that formula. So tan 29 equals x, okay, over 14. Now that we're looking for that variable that's at the top of that fraction, all you need to do is times the left side by 14 and you'll get your answer. So 14 times tan 29 equals x. And normally you rearrange it so your x is on the left, so x equals 7.76 centimeters. And finally the last example, so again we're going to label our triangle. So we've got the opposite, the adjacent, which is our 53 meters, and we're looking for that hypotenuse length. So the formula we're going to have to use, if we have the adjacent and the hypotenuse, we have to use cos, because that's the only one that uses the adjacent and the hypotenuse. So we write out our formula, cos theta equals the ratio between adjacent and hypotenuse, and then we populate cos 62, our reference angle, equals 53 over x. And again, because that variable is on the bottom, we can just swap those two. So we're going to get h equals 53 over cos 62. Okay, again, you'll need to use your calculator for these, and we get h equals 112.89 meters. Okay, we'll leave the video there, and hopefully you've got a bit out of that. Goodbye now, and we'll see you next time.